Greetings. In this series, we are going to look at mathematics from around the world. Math is a subject that is studied around the world by various peoples and has involvement in culture at various levels. We have images used as artwork from geometry, and we have geometries that were studied because someone was looking for one thing, discovered another, and then that was applied to something else. In this series, we want to look at mathematics from around the world and the various things that connect us as a people in a beautiful creation. I hope you enjoy worldwide mathematics. In this video, we are going to focus on India, and specifically we are focusing on Bhaskara II the Learned. He is known for his proof without any words except for one, and an image. He has a square which is turned at an angle inside of a square, and lines extending off of each of the sides, creating a series of 4 triangles, and the word behold with it. What this is a proof that the Pythagorean theorem as we know it is true. He also worked with a couple other aspects in geometry. He dealt with regular polygons up to 384 gons and came up with a valuation for pi. Bhaskara was born around 1115 and died around 1185 in Ujjain. He was an astronomer, mathematician, and astrologer, and he was head of the Ujjain Astronomical Observatory. He wrote several books that dealt with mathematics. One of them specifically dealt with algebra. We want to prove that a squared plus b squared equals c squared using this diagram. We're going to add some measurements of a, b, and c to the diagram and then show how we can get to this statement from the diagram. For the individual triangle that we see here at the top, we're going to label the altitude here as A, the base here as B, and then the hypotenuse as C. And then we will continue that pattern all the way around. All of the triangles are congruent. This ends up being a square in here and a square on the outside. So this hypotenuse again is C, this altitude here is A, and this base is B. We continue around and we do the same thing. So what is the measure of this segment in here that makes up the side of the square on the interior? Well, it's the length A minus this length B. So this is A minus B will be the side length there. So looking at the interior square, we'll call that S sub 1. The area for the interior square will be A minus B squared. And that will expand out to be a squared minus 2ab plus b squared. Looking at the exterior square, we'll call it S sub 2. We have the base times the height, so this is c squared. And then the area for an individual triangle, I'll call t. This is going to be base times height times a half. So these are the areas. If we take 4 triangles and we add it to this small square, we should have the total area of the larger square. So let's take a look at that. The larger area is c squared, and that's going to be equal to the smaller square, which is this, a squared minus 2ab plus b squared, plus 4 of these. I can make a side calculation here and multiply 4 times this value. and get 2AB. So I can add 2AB in here, and this is all of the triangles together. We now notice that I have a negative 2AB here and a positive 2AB here, so these are canceling, leaving us c squared equals a squared plus b squared. We can just flip this around by the symmetric property of equality and have that a squared plus b squared equals c squared, which is what we were to prove. So, as Bhaskara II said, behold, this picture is a proof of the Pythagorean theorem. Hopefully you are finding some mathematics in your part of the world to explore and enjoy. Cheerful calculations.